Have you ever wondered how a brain can recognize a face in just one glance? But a computer needs time, power, and lots of data. Today, we will be talking about neuromorphic computing, how it works.
Neuromorphic computing is a type of computing that tries to work like human brain. The word neuromorphic means brain-like. This topic is important because neuromorphic computing could be future of artificial intelligence. It can make computers, robots, devices much faster, smarter and use much less energy.
In this presentation, we will explain what problem current AI has, what makes neuromorphic computing unique, how it works using spiking neurons, and a real-life example like Intel Lohi chip. What's wrong with traditional AI? Traditional AI systems have some big limits. First, power usage. They use a lot of energy. A regular AI chip might use around 100 watts, but a neuromorphic chips like Lohi use just 0.1 watt. Second, speed. Traditional AI works in steps or batches. Neuromorphic chips work in real time, just like how we react quickly when something happens. Third, learning. Traditional AI needs lots of labeled data to learn, but neuromorphic system can learn from just a few examples, like how we remembered something after seeing it once. Also, traditional computers keep memory and processing separate. Neuromorphic chips combine both, like how our brain stores and processes at the same time. The diagram shows the difference. On the left, data keeps moving between memory and processor, slow and requires more power. On the right, neuromorphic chip combine both using spiking neurons, faster and more efficient.
What makes neuromorphic computing special? Let's take a look. Neuromorphic computing is inspired by how the human brain works. The core principles that make it unique are spiking neurons. So tell me, do you think your brain is always sending signals even when you are resting? Not really. It works only when it needs to. That's how spiking neurons work. Plastic synapses. Now, how do we learn things like riding a bicycle? We repeat them. Our brain strengthens connections when things happen together. Neuromorphic chips mimic this with plastic synapses that learn over time using Hebbian learning, which means neurons that fire together wire together. So these chips can actually learn like a brain. Our brain can do many things like walking, thinking, and talking all at same time. This is known parallelism. How does it work? Let's begin with how neuromorphic computing works. It uses spiking neural networks or SNNs. In neuromorphic computing, SNNs helps create brain-like systems that learn and adapt just like humans. Look at the left side of the slide. Shows the network structure of an SNN. Here we have 784 input neurons. These are like the first layer that takes in information. For example, form an image. Then we see excitatory neurons and inhibitory neurons. Excitatory neurons pass the signal forward. Inhibitory neurons slows it down or stop it. This is how the network controls which signals are strong and which are weak. Some connections have positive weights, they increase the signal, and some have negative weights, they reduce the signal. Finally, the classifier neurons try to recognize patterns, like identifying if the input is the number 3 or 7. Now look at the right side of the slide. On the right, we see how spikes travel and how learning happens. We start with an input spike train, a pattern of signals coming in. Each signal is multiplied by a weight, W1, W2, W3. Then all signals are added together. If the total is big enough, the post neuron sends out a spike. This is called firing. Just like in our brain. They are smart, fast and save energy, which makes them great for building. Let's take a quick look at Intel's Lohi 2, a super smart brain-like chip. First, the features. It's 100 times more energy efficient than normal system. It can even recognize hand gesture using just 0.1 watts of power. Neuromorphic computing is a game changer for the future of AI. By mimicking how our brain works using spiking neurons and energy-efficient chips like Intel's Lohi, we can build smarter, faster and more eco-friendly systems. Whether it's helping doctors, robots or rescuers,
This brain inspired tech is already making a real difference, and it's just the beginning.